to introduce what is the future in my research area and what is my lab doing here. So this is me. This picture showed me when I was 80 kilo. All right, right now I'm 66. All right, this is a brief of myself. The only thing I'm going to share with you is that I'm really old. Okay, I got my degree in the last century, 1992. So this year I'm 60. So I'm an old man. It's about time to ride my horse into the sunset. Okay, so before I retire, so it is my obligation and duty to give a chance for those young men who are interested in this area. And I cannot guarantee that you will be a millionaire, but at least I can give you a chance to change your life, not just your life, the life of you and your family.
Yes.
So right now I publish around 150 journal papers, 300 conference papers. I myself have 160 patents, and right now I'm the vice president of the Office of Research and Development of this school. I'm also the director general of Underwater Vehicle Research Center. So this is a brief. Okay, I'm going to skip this part because when you are as old as I am, well, of course, you will receive some honors. Okay, I also host a few international conferences. All right, that's nothing. So where am I? Okay, this show you how far between you boys, girls, and me. Okay, about 7 hours flight in the sky. If you want to swim, it will take a little bit longer, right? Okay. So, okay, what IC means? Okay, as Ms. Chen say, IC is an integrated circuits. But I always tell my students, okay, studying and learning is fun. So sometimes I'll tell my students, you can think IC is an interesting circuits, right? Interesting because this thing, you might have a chance to change your life. I'm gonna show you something here. This is done by my students. It was taped out by the world leading company TSMC. And this is a chip, a teeny tiny one. All right. So my lab, all my students must tape out and measure it. Okay. Otherwise, I won't sign anything for anyone. All right. Okay. Because all my students must be qualified as IC design engineers. Okay, and as addressed by Ms. Lin, so what's the future? Okay, this is my viewpoint. It might not be in alignment with anyone else, but what I'm thinking, okay, because I've been teaching for 30 years. So the first thing I think in the future, next 30 years, 3 decades, the first thing going to change our life is the semiconductor material, because Europe, they just passed a bill that 75% of the new products must be recyclable materials. And this new rule will change a lot of games, right? And the second thing is the third generation of semiconductor is coming. So one of the major target in the future is a silicon carbide. Silicon carbide is a very important thing. If I have a chance, I'm going to explain more, but I don't think I have too much time. And the second one is a wireless communication. Right now, everybody is talking about 5G, right? So in fact, many international power players, they are talking about a 6G and a 7G, okay? And they are talking about to deploy very low orbit satellites. It's about space and satellite communications. Number 3 is about the autonomous vehicle that Mr. Chen just said. It's AI. Without AI, okay, none of the drone or intelligence can happen. But AI is the future. But AI has a very big problem. I'm going to explain later. Number 4 is a biotech. Biotech stands for the integration of biology and electronics. Because biology is very old stuff, but with the help of electronics, it will give us a chance to bring the health home farm to every family. So this is about the biotech. Okay, so the future, let me summarize everything here. The future of these 4 things come down to these 5 important components. Number 1 is sensor. Okay, number 2 is a power supply. Okay, how can we manage the power? Okay, how can we predict how much power we left? Okay, what could be the dangerous thing? Because power is also dangerous. Because if you manage it wrong, it causes very dangerous the consequence, like explosions and this kind of thing. Number 3 is the storage. Everybody like big computer, big memory, big hard disk. Okay, the storage. And number 4 is algorithm. Algorithm is the backbone of artificial intelligence. Number 5 is data. Data is valuable. So how do you harvest and collect data is very important. So everything right now comes down to one thing only, chip. Okay, and let me quote Ms. Chen's stuff. Okay, even Musk, the Tesla is right now is talking about doing the chip by their own, because right now I'm telling the cruel fact about the chip. So why do you come to Taiwan? Because Taiwan is the only country in the world can give you the full supply chain of everything in semiconductor research and everything. Okay, I'm going to tell you what is that. If you're talking about making chip, not just building a plant, okay, you have to have an entire supply chain. Otherwise, it won't work, right? So Taiwan give you everything you need in this area. Okay, this is a very important diagram to show you why Taiwan matters. So IC supply chain stands for 3 things, okay? The global ranking, okay, current status of Taiwan, and related industry. If you see the upper left-hand side, we are the number 1 foundry service in the world, 70%. Okay, number 2 in the IC design, next to USA, we are number 2, about 20%. USA, I think it's about 60%. Okay, we are number 2 in memory, number 1 in packaging and testing. So this stands for the full supply chain. We are number 1 or number 2 in the world in the full supply chain. And we have right now over 300 IC design houses on this teeny tiny island. Okay, Taiwan has only 23 million people. Okay, and India has 60 times of this population, and I think it's 100 times of land. All right, never mind. I'll just tell you. So my conclusion is that every 2 out of 3 chips in the world, okay, comes from Taiwan, because they are made in Taiwan, basically. So this is a place, if you wanted to learn IC design or IC manufacturing, IC industry, this is the best place you can find. So this is the entire supply chain of everything. So when a Tesla talk about wants to do the IC manufacturing, they must have to do something. They must bring everything to their lab. It's going to be very hard. Okay, so IC design, okay, it's on the upstream of this supply chain. Okay, and the foundry packaging and testing is the lower stream. Okay, so when you're in the high stream, you're going to have a very high added value. Okay, this is where we are, where my lab is. So the process of IC design or IC manufacturing, look at this. First thing, you got to have money, capital. You got to have land. You got to have electricity, water, this kind of thing. And you have a wafer. Then IC design jumps in, do the design on using the computer. Then the system integration, you have to talk to your partners, your managers, your project leader, and integrating everything together. Then send the design files to the foundry service. All right, and then this is the tape out of the chip, and you're going to package it, look like this way. And this is the one in my hand. Okay, it's a long process, 3 to 6 months. And students always worry about one thing, where I'm going to work. Is it easy to find a job, and how is the job paid? Let me use this diagram to show you. This is Ms. Chen asked me to find. Okay, this is the diagram, the photo of Hsinchu Scientific Park in Taiwan. This is the largest scientific park in Taiwan. Left-hand side is a number of companies in semiconductor. As you can see, it's increasing every year. And the right-hand side is the number of employee job offer every year. It's also increasing. Right now, this is around 5 years ago. I cannot have the updated the new data up to 2020. I checked the newspapers. Right now, we have more than 300,000 jobs in that scientific park. Okay, we have 6 scientific, but this is only 1. All right, so as you can see, this is very promising area. So what is the pay? I'm sorry, I don't have English version, so I may explain to you. This is the job description on the website, very famous website. Ms. Chen know what I'm talking about. I'm sorry. In the red box, okay, there are 2 job offers here. On the top is called analog IC design. In the bottom one is a digital IC design. As you can see, these numbers are in Taiwan dollars. Okay, if after you translate to the money exchange, it's around 3,000 US dollars per month. This is only for the entry level, just entry level. If you are experienced IC designer, the money could be double or triple. All right, because you are very precious and valuable. And in this area, it's very competitive. Okay, none of my students, okay, as every student in my lab, as long as they get my signature and they tape out the chip like this one and do the measurement, okay, everyone got a job. Okay, job offers are like 4 to 5 job offers, and they will select one. And if you and not just month salary, okay, you also have the right to get the stock option and bonus. All right, what is my lab doing? Okay, my main mission in my job, in my lab is that, okay, I train my students into IC designers. Okay, then second thing is I also help young scholars, young professors to join my lab, and they can have a very quick start with their academic career. Because the young assistant professors, they are very pitiful because they don't have resources. Okay, I gave them the environment and some help so that they can have a quick start. And the number 3 is that, okay, it's my personal interest. I like to work with industry to develop something useful and can make some money. This is the number 3 mission. So what I'm doing right now, the major, I work with a lot of ICs. Okay, I always about one thing. As long as the IC can make money, I'm interested. Okay, so let me give you 4 examples. The first one is a biotech, biomedical IC and electronics. Number 2 is a power. It's highly correlated to the EV cars. Number 4 is AI. And number 5 is my new interest is underwater thing, okay? So the biotech, our goal, because I was asked by a doctor friend, they say all the equipment in the hospital are imported, either from the Europe or USA, very expensive. For example, the spinal stimulator is over 200,000 NT dollars. It's unaffordable to a lot of people. Can we make it cheaper and affordable for everybody? I said, give me some time. Let me find out whether we can do something about it. So this is a very successful example. Everybody got sick. So one of the doctors say, okay, we have a lot of biomarkers, and the biomarkers tell a story. But the thing is, if you want to go to the hospital and do a lot of tests, that's very costly. And it's, for those people living in the remote area, they don't have this kind of resources. So can we develop something fast and very high precision to help people to find out in the early stage that they're in the danger of a tumor or a cancer. So this is one example. So this is an industrial job. So we developed this system over here. I cannot take all the credit on my own, but the thing is, as you can see, the FPGA and ASIC was developed in my team. Okay, of course, the company developed all the cartridges, the microfluid, and the kind of thing. Okay, so this is a very successful project. And another interesting is that, okay, I was asked by one company, and they have a very special material. And this material, when you bend it, it can generate power. So, okay, that's fine. So this is a raw material. So I combine with my chip, I put in a shoe. All right, and then run the video here. So this is a video. You can see that you can turn on the LED here. So that is very interesting because what? Because there is no battery inside. All you need when you walk, you generate the power. And then you harvest all the power. You can send out a warning signal So they are use this kind of stuff for the kids because kids might be kidnapped, and the elderly they might when they are old they forgot where they are. So we equip this kind of thing in the closer shoes so to prevent bad things happen to the old guys and the kids. Okay, and this one is another thing is that the EV car. EV car is the future, as Ms. Chen said. So what is an EV car? This is an EV car. EV car is just like, okay, you have 4 wheels, you have a mobile phone, okay, but the thing is, you got to be careful. Oh, the mobile phone or the electronics, they are working in a very low voltage thing, okay, 3 volts, 5 volts. But when you try to drive a car, you need to drive the motor and the wheel. You need a very high voltage and high current. So this is a very dangerous place. It's a boundary between the high voltage and the low voltage. Okay, everything else, your electronics is software. So what we do, okay, we have to understand what the situation of the battery is. This is a video from the newspaper, from our news report, but it's in Chinese. I'm sorry. Yeah. This will show you that when the battery is not properly monitored, it will explode, just like this one you see on the screen. And this guy's house was tortured, okay, and everything was blown away. So this is very dangerous place, a dangerous thing. So we have to watch closely when we use this kind of device because it's a high voltage and high current. This is bad things happen to the poor guy. All right, and of course we have another industry project. This was asked by my friends. So this is a very large battery. We can see the condition each one of them. So before bad things happen, we can take proper actions to stop this kind of tragedy happens. Okay, and the next one is a very amazing one, is that the AI. Okay, AI is not new. Okay, but we are the first team in Taiwan. It's a very ugly chip. All right, so this is the some interesting result. In our database, we have a clownfish, turtle, jellyfish, diver, ray, devil ray, slimefish, shark, and we are even able to recognize human waste like a glass or the pet. Okay, so as you can see here, we can see the turtle is coming, and a lionfish is kind of thing. So this machine really works, right? And this is another interesting experiment in the big pool. See that this machine follow a special topic. Okay, something suspicious. Okay, we just follow it. All right, and this is a chip that we developed. This is the AI chip. It's very, very expensive. It costs us $2 million. And because of this chip was reported, okay, then the world leading #1 company, TSMC, came to us to ask us for join the project. And they are going to use very advanced technology to tape out the same thing. Because we don't have too much money, we only use a very old legacy process, 180 nanometer CMOS. They're going to use a 40 or maybe 7 nanometers. It costs over $100 million for that project. All right. Okay, and the number 4, the last project I introduced is that not only the unmanned machine, we like to build a man manipulate machine in the water. Okay, this is the prototype design. Okay, this is a big fellow, 4 tons. Okay, we have 2 pilots inside, and this is a big machine. It's about 4 meters high. Okay, this is we call that man submersible, MUV, underwater vehicle. Because we have pilots inside, so we must have a supportive system, life sensitive systems, and we are going to use this machine for the rescue mission, exploration, maintenance. If it is necessary, the defense department might ask us to weaponize it, but which right now we don't want to do that because my lab is a peace-loving lab. Okay, unless we have enough big money, so I might change my mind. This is the first testing in the harbor. As you can see, this is a big fellow, right? And the water is very dirty. Never mind, this is the first testing. And testing just fine. We have 6 partners to develop this machine. Okay, then we deploy in the real sea. Okay, never mind. Everybody can see the picture, right?
Yes.
So we are cruising on over the water first. Make sure everything works just fine. Okay, nobody gets hurt. Then we start diving, like what the military do. And we hit the bottom of the water. We are show you what it's going to see. Okay, we hit the, see that? A lot of mud coming up. This is the bottom of the sea. Okay, and hit it, and we stay there, and it comes back. And we are going to test it the next week, 48 hours from now. Again. Okay, so let me tell you how is the job perspective. Okay, as long as you meet this requirement, I guarantee you find a job. If you don't, okay, let me know. That it's impossible. Okay, first thing is that you publish a paper in the following very good journals or conferences. All right, IEEE, JSSC, ISSCC, okay, and these conferences. You gotta publish something. Then you tape out a chip, advance the chip, and measure it to prove it works as expected. Okay, when you go to the interview for IC designer, trust me, all the HR or the project will ask you, what have you done? Have you ever taped out the chip? Have you measured it? How does it work? Okay, because the student has experience to tape out the chip, okay, and another one has no experience. What will you choose if you are the manager? Think about it. Think about it. Okay. Of course, you will choose the students who has taped out the chip and measure it, because this kid has a hands-on experience of everything, right? Okay, not just simulation, not just some theory, right? Because you have the hands-on experience, you understand all the problems from the design to the end, to the verification. Okay, this is very important training procedure. All right, and the number 3 is that you got to file a patent. Okay, the patent is not for me. If you can file a patent, the student file a patent, you know what the claim is. Okay, you will know, okay, how to defend your skill, your invention, or your idea, or your circuit. Okay, you understand, do not infringe others, okay, idea. So the patent application training is also required. Okay, this is in my lab. I ask students to publish 1 paper, international conference paper at least, tape out chip and measure it and make it work. Okay, number 3 is that you got to file a patent. Okay, right now I have about 2 weeks ago, 2 of India's students just passed this bar, and they got my signature and get a degree. And students always want to know how much money they can get, financial support they can get in university. Let me explain to you here. So for those students, for all the foreign students, okay, can apply for the tuition waiver, the scholarship for the university authority. And right now, our university give top 50% students at least a tuition waiver. All right, so you don't have to pay a penny for the tuition for the first year. In the second year, okay, you have to be the top 50% of those who had already got the tuition waiver, right? You understand? In the first year, we select half of them to get the tuition waiver. In the second year, the university will select, okay, the half of this first half, again, to give their second year tuition waiver. So it's quite competitive. And this is from the university. in my lab, if you can contribute and you work hard for the project, trust me, I have enough RA for you to get. Okay, the more project you do, okay, the more money you get. Okay, because it's fair. In my lab, okay, I don't just have foreign students, I also have local students. Okay, I have to be fair for every student. I told them that specifically, okay, you are no difference to me. Okay, as long as you are students in my lab, graduate students, you are all the same. Whoever can contribute, I pay them with a research assistant RA. All right, this is the second financial resource. Number 3 is that because India students has a very important strength feature. Okay, your English is very good. Right now, my school is turning all the courses, okay, into English. So we need strong support from the teaching assistant. So this year, next semester, I will tell the department I like to hire 2 India students as my undergraduate English course teaching assistant. They really received TA-ship from the department. So if you are India students, okay, you have possibility to receive 3 financial support from the university, from the department of TA, from my projects. I hope my explanation is clear to everyone interested. Okay. Okay, that's it. This is my contact information. That's me in the water. Okay. If you cannot find me in the water. That's